5 is complex zeros and the fundamental theorem of algebra. Okay, we have worked with zeros, yes. We've worked with zeros. Specifically in this unit, we've been finding all of our real zeros so far. Okay, we've talked about how to do that. We're going to go now more into complex zeros. And when we talk about complex zeros, that means we're talking about our friends, the imaginary numbers. Okay, so we're going to have imaginary zeros too. As you scroll down here, you'll see some I's in our problems. So, okay, so first of all, fundamental theorem of algebra. A polynomial function of degree n has n complex zeros. So that's just saying if a degree of equation is like x to the fifth, then that means there's going to be 5 zeros. Not necessarily all real, some combination of non-real and real. Okay, some of these zeros may have a multiplicity greater than 1. So it might not be 5 unique zeros. There might be multiplicities that cause them to repeat. So that's fundamental theorem of algebra. Kind of what you already know, really. We've already talked about that, just not by name. And then we're also going to use the linear factorization theorem. Given the function f of x of degree n, then f of x has precisely n linear factors, where a is the leading coefficient. So if f of x is degree n, it has, so if it's degree 5, I keep using 5, that means there are 5 linear factors. They might not be real factors, okay? In other words, they might have i's in them, so we can't use our traditional factoring methods, and that's where our synthetic division will continue to come into play. And then our other theorem, before we get started, given a function f of x with real coefficients, if a plus bi is a 0 of f of x, then so is its conjugate, a minus bi. This is probably the important one today, because when we get to it, whether we get to it today or Monday or whatever, we're going to have to remember they're not always going to be nice and say, okay, this and this and this are zeros. If they tell you that a plus bi is a 0, you have to be smart and say, okay, that's an imaginary number. That means it's conjugate. So conjugate, you're keeping the two pieces the same and changing the middle sign. So that's saying that, okay, if a plus bi is a conjugate or is a 0, then so is its conjugate. They always occur. I've talked to you about how they occur in pairs. Okay, like how the imaginary ones occur in pairs, the irrational ones occur in pairs. And this, it has to do with the conjugates here. Okay, example 1. Write the polynomial function in standard form. Identify the zeros of the function and the x-intercepts. Okay, so standard form. How do I write f of x equals x minus 2i times x plus 2i in standard form?
You have to distribute.
Distribute, FOIL. We need to multiply it out. Standard form is terms added and subtracted together going from highest power to lowest power, right? So if we FOIL this out, x times x is x squared. X times 2i is 2ix. Minus 2i times x is minus 2ix. Minus 2i times plus 2i minus 4i squared is what I'm writing at for right now. Minus 2 times positive 2 is a negative 4. I times I is I squared. Now, standard form, do we leave it like this? Absolutely not. What kind of cleanup do you see here? Okay. 2ix minus 2ix is gone. Yeah. Remember, minus 4i squared is the same as saying minus 4 times minus 1, right? I squared is equal to negative 1. So minus 4i squared actually becomes plus 4. So what do we have remaining? X squared plus 4. And that is my standard form. Okay? Now, the other two pieces of this are identify the zeros. We'll get to the other one here in a moment. What are my zeros? Or how do I find my zeros? Okay.
Would be plus 2 minus 2.
Not exactly.
It'll be 2 and 2, right?
Not exactly.
It'll be square root of 1. Yeah, because it's a negative on the square root, right?
So, okay, so one option is you can set this equal to 0, yes?
Oh, I see.
X squared plus 4 equals 0. And if we want to do it that way, I have kind of an easier option if you want, but x squared plus 4 equals 0. Subtract the 4 over, right? X squared equals negative 4. And then we take the square root. What's the square root of negative 4? Plus or minus the square root of, or square root of square root of negative 4. We do the square root of negative 4. Square root of 4 is 2. Square root of the negative is I. So plus or minus 2i. Now, my easier route. Didn't we already have a factored form here? Could we have just set each of those parts equal to 0? Yeah. And here's the deal. Looking ahead, once I get this boiled out, I don't want to have to undo it. Okay? So I would just say take the factors you know. X minus 2i equals 0. X plus 2i equals 0. Now, in this case, did it work either way? Once you got your math all straight? It does. So we know that x can equal 2i or negative 2i. You can also write that as plus or minus 2i. What is that? Those are my zeros. So we've got zeros. We've got standard form. What else was I asked? X-intercepts. Where is this graph going to cross the x-axis? Technically, no.
4.
Where does a graph normally cross the x-axis?
On 0.
At its zeros, yes? What are my zeros?
Not real.
Not real.
It'll, yeah.
I hate
So since there are no real zeros,
will not cross.
this graph will not cross the x-axis. Now, if you graph it on your calculator, what are you going to find? Just that. Okay? So the idea is not to graph it on the calculator. That's not how you're supposed to do this. However, is a good backup, is a good proof. Okay? Okay, so can you type in the factored form?
Oh, you type in the factored form.
Well, no, we can't really type in the factored form here. You type in, I would have said type in standard form.
Oh, could you type in the first one?
Is there a way to type in i's in that?
Yeah, it's the second.
I don't know. Try it and find out.
Alright, you type in the standard form. Okay. Well, nothing.
So I'm going with no then.
X squared plus 4 does not cross the x-axis. Well, it doesn't. It doesn't. Oh, but I did. What did you do? No. But it was a top, so it wouldn't.
You shouldn't have to zoom out if you're on a regular screen.
Yeah, no. Okay. Can it, is it on the axis? No, it's right there.
Okay. I say that's something for me to look at later because now you've got me curious. But I've always gone to the idea of you can't type an I in.
Right. I mean, maybe you can't, like, to put it into the graph.
Yeah.
There is an I, but I just don't know what you'd use it for if you can't put it into the graph. I mean, it looks like an I.
It does. I just don't know if it's just an I or if it has a different value.
Different eyes.
Like if it's just a variable. Yeah, it doesn't graph anything there.
Right.
I'm not sure why it doesn't graph anything there. So that's an interesting thought. Yeah, I don't really know. As much as I know about these calculators, there's a ton that I don't know. And that's where it falls. You know, some of you guys know more than me on certain things of this calculator. Did I spell imaginary wrong?
No.
Yeah.
That's what it
Is
Is it
is.
is it ERY or ARY?
There. Oh.
I am a math teacher. Now, do I still expect us to try and get the spelling right? I do.
Yeah.
However, I am a math teacher. Granted, I also make math mistakes. So
Miss Holman also does during tutoring.
what?
She doesn't know how to do math.
No.
We have to tutor the math.
Yes. Okay. B. So first of all, on B, we're going to start by writing it in standard form. How am I going to do this on standard form?
You're gonna have to put all that. Distribute.
Basically, you want to think about 2 sets of FOIL. And then after you do 2 sets of FOIL, you will then multiply those together. Okay, so what do you know about x minus 3 times x minus 3?
X squared minus 3.
X squared.
Or you skip it right to.
I was going to skip right to it to save myself room. Minus 3x and minus 3x is going to be, no,
Oh, minus 6.
minus 6x plus 9. Now, when I multiply these next two, notice they are conjugates, yes?
Yeah.
So my middle terms should cancel out. Let's FOIL. X times x is x squared. X times square root of 2 times I, and negative square root of 2 times I times x. It's going to cancel. Negative square root of 2i times square root of 2i. What does this multiply out to be? No?
4.
A negative times a positive is a negative. Square root of 2 times square root of 2.
Oh.
2. Or you could say square root of 4, but square root of 4 is
Oh, is the I?
2.
No.
I times I squared. What is negative 2i squared? Positive 2? Because I squared is negative, right? So I'm just going to say x squared plus 2. Are you with me?
Yeah.
It took a moment, right?
It did.
But we're there. And are we done?
No.
No, we've got to multiply again together. Okay. Basically, you have 3 terms times 2 terms. We're going to have 6 terms, whatever order you want. I tend to take my 2 terms and multiply it by the 3. So I tend to take x squared, multiply it by the first 3 terms, and then the 2 times the first 3 terms. In the end, we're all going to end up with the same answer as the plan. So x squared times x squared is x to the 4th. X squared times minus 6x, minus 6x cubed. X squared times 9, 9x squared. And now I'm going to multiply everything in the first parentheses by 2. 2x squared minus 12x plus 18. Clean up. My cleanup, all I can do is add 9x squared and 2x squared and get 11x squared. Oh, crud. What did I do wrong? Well, I don't agree with my own answer up here, so
That's what I.
Oh wait.
That's what I.
Oh, so maybe I just messed up on my answer key?
No, there should be an x to the third.
There is.
I have mine as -6, is that right?
Yeah.
Yeah.
Minus 6x.
What's your answer, Keys?
My answer key says -12x cubed. But you know what? My answer key, I got that straight from multiplying, and there is no -12x cubed.
There's. I don't know. Like that.
Because
Yeah.
2 times -6x. Right?
Yeah, it's a mistake on my answer key. Okay, as I'm redoing the notes, I'm writing out new answer keys, and I goofed that one.
It's okay.
Okay, so are we in agreement that this is right now?
Yeah.
Okay. What is this?
Standard simplified or standard.
Standard.
This is our standard form.
Boom.
Okay. Next, I want to know what my zeros are.
Uh, 3
3 plus minus
2 square root of 2.
Okay. So officially, to find our zeros, set each factor equal to 0, right? So we could say x minus 3 equals 0. I could say x minus 3 equals 0 again, but do I need to? No. X minus square root of 2 times I equals 0. And x plus square root of 2 times I equals 0. So with that in mind, when we solve, as you said, we have 3, and we have plus or minus square root of 2 times I. And those are my
0.
zeros. Now, how many zeros do I have?
3.
3. Technically, how many should I have?
4.
4. However, I'm going to argue we do have 4.
Oh,
Because, what do you know about 3?
there's 2 of
There
them.
was.
It occurred twice, right? 3 has a multiplicity of 2. Okay, and so that counts double, so to speak. Okay, so I had 4 factors. I have 4. Okay, lastly, x-intercepts.
Can it cross through 3 twice?
No, it'll just cross. Actually, what it will do is it will touch at 3. I don't know if you guys remember that or not.
Oh yes.
If the multiplicity is even, the graph is going to touch 3. But that still counts as an x-intercept. Okay, so we're going to have an x-intercept at 3. Anything else? No, the others are imaginary, right? So your only x-intercept is going to be x equals 3. Okay, because we're only looking for real zeros in that case. Okay? You know, not that it really matters because we've already kind of talked about it, but I realized up here in my notes I had written that I, just in case you have forgotten, I is equal to the square root of -1, and I squared is equal to just -1. We've already used that fact though, haven't we?
Sure.
So it must have came back to you. Okay, make sure you have everything you need from here, and then we're going to look at example 2. Example 2, ask us to write a polynomial function of minimum degree in standard form with real coefficients whose zeros include -3, 4, and 2 minus I. Okay, you ready?
Yep.
We have to write it in standard form, but where are we going to start? We're going to have to start in factored form.
Yes.
What do you know? A 0 of -3
X plus
is going to be a factor of x plus 3. A 0 of 4,
X
Minus.
x minus 4. A 0 of 2 minus I,
2 plus
Now keep in mind, when we're putting these numbers in, what are we doing? We're doing, this was x minus the 0, so x minus -3. This was x minus the 0, so -4. So we're still, as a factor, we're still going to do x minus, what are we subtracting?
2 plus I.
We're subtracting the given, which is 2 minus I. Now, here's the deal. I wrote that as x minus parentheses 2 minus I. When I write that without those inside parentheses, x minus the quantity 2 minus I is really going to become what? X minus 2 plus I. Okay? And that may have been what you were trying to say. I don't know. But, so either way to write it is correct. In the end, we're going to want it written like this because of our step to go to standard form. Do we have all of our zeros?
I feel like it's a no, but I don't know why.
I feel like it's no, because the only reason is because you asked.
Because I asked exactly. So we have all of the zeros stated. But there's a zero they didn't tell us
Well, that's not me.
that we have to know.
How are
Zero.
we just supposed to know that?
Is it 0?
She's
No.
about to tell us something about it.
Technically, I already told you.
Well,
Technically, I already told you when we talked about our 3 theorems at the top of the page.
oh, we have to have A minus BI.
So complex conjugate zeros theorem. If A plus BI is a 0, then
But
A minus BI is a 0. What does that mean for our problem?
x plus
So it'd be X
If 2 minus I is a 0,
2 plus I.
the conjugate of 2 minus I is
Plus
2 plus I. Okay, so since they told me 2 minus I have to know, okay, that's a complex root. I have to use the conjugate.
So is that x plus 2 minus I?
So this one, I'm going to start off right in basic form. It's x minus the 0. So it's x minus the quantity 2 plus I. So this one is x minus 2 minus I. Okay? I know, it's a lot to take in there, isn't it? Now, is this how I get to express my answer? No. It wants standard form, which means we have to what?
Foil it out.
You got it.
We got to multiply this out. Okay, now, one thing I always say as you go to FOIL this. Yes, there's a lot of math here, okay? I'm not going to argue that. But what will make the math easier as you pick pairs to FOIL together, always FOIL together your conjugates because more stuff will cancel. Okay? So what I'm saying when I say that is we're going to have to FOIL these two with each other is your best move. And that means by default I might as well go ahead and FOIL x plus 3 and x minus 4. Yes? So x plus 3 times x minus 4. X squared you can say minus x, that's fine. Since I know I have a cleanup step in my other one, I was going to go ahead and say minus 4x plus 3x and minus 12. Okay. If you already cleaned it up, perfectly okay. In fact, that might be, I usually do that on my own. So now, on this one, we're multiplying trinomial times trinomial. When you're multiplying 3 by 3, we're going to end up with 9 terms. Several of those are going to cancel out, though, because of conjugates. So, x from the first parenthesis times everything in the second parenthesis. So, x squared minus 2x minus ix. Minus 2 in the first parenthesis times everything in the second parenthesis.
Minus 2x plus 4 plus 2i.
Okay? I times everything in the second parenthesis.
Plus ix minus 2i minus I squared.
The roll.
Okay? Clean up the first parenthesis. And you may have already done this. X squared minus x minus 12. Okay. In the second parenthesis, anything fun happening?
Ix.
Minus ix cancels with plus ix.
2i.
Plus 2i cancels with minus 2i. Minus I squared would be minus negative 1, and so that will become plus 1. Notice all of my i's just went poof. The i's are gone. If you're multiplying conjugates, the i's should be gone. That's the key. So clean this up. I have x squared
Plus 4.
minus 2x, so minus 4x. Plus 4 plus 1 is plus 5. And
Foil again.
FOIL again. 3 by 3, so 9 more terms. I'm going to do x squared times everything in the second parenthesis. X to the fourth minus 4x cubed plus 5x squared. Minus x times everything in the other parenthesis. Minus x cubed plus 4x squared minus 5x. Sorry, I probably should have given you a warning about the space requirements on this one. And now I'm going to distribute my minus 12. Minus 12x squared plus 48x minus 60. Final step. Clean up.
I went ahead and did all color.
Yeah.
It was a whole lot easier to do that. But no, you absolutely need 3 of them. Because one page messed up. So it's 29.
You're good.
All right.
Thank you.
All right, sorry to interrupt. I need to talk to you after that.
Okay.
All right.
Am I in trouble with Mrs.
Must have
Reeling?
messed up. Must have messed up.
I was supposed to stop and talk to her earlier this week. Might be about that. I don't know. Okay, guys. Did you get what I got? X to the fourth minus 4x cubed and minus x cubed is minus 5x cubed. 5x squared plus 4x squared is 9x squared minus 12x squared is negative 3x squared. Minus 5x plus 48x is 43x, and then minus 60.
Is that it?
That's
All
it.
you do?
Whew, that's it.
That's all.
That's all we do?
That's all. Just that little itty bitty problem. That wasn't much.
You know, I think PhotoMath would actually do that.
Not on a test, it won't. Okay, so
I'm sure we could figure it out.
write a polynomial function, minimum degree. Minimum degree is in, they're not telling you that this is going to be degree 4 because they're not trying to give away that, oh, we didn't tell you all 4 zeros. Okay? So I feel like that's kind of why they say minimum degree. Like, we don't want to give you that hint. So minimum degree, it's degree 4. Real coefficients because all the i's dropped out as they should. Okay? And there we go.
The next one works. I feel like it's worse. It's worse.
She's got a lot of blue on her.
You know,
5.
I will say, beware, I ran out of room on mine.
I just feel like I think we've used a lot of our brain power today. I feel like we can save this one.
I gotta take a test.
Well,
See,
That's
she's
next
already
hour.
died.
Stack could like he could start on his test early.
let's go ahead and get
Get
this
him
done.
down.
Let's go ahead and get this done.
How am I supposed
Example 3, and then I'll put 4 and 5 on Monday.
How am I supposed to think?
Is that all we have left?
I'm gonna have brain.
Yeah.
But
So.
Let's see who can get done first.
No, because I'm gonna mess up and then have
Missing
to go
key.
my bed.
Oh, and
I don't know, is Katie, are you glad you came today or not now at this point? I don't
Yeah,
know.
I was glad I wasn't there last night. They had a whole issue with the hotel.
Oh my gosh, I heard about that.
Yeah, the
Like
boys had
roaches.
bed bugs, and the girls didn't have a lock.
Oh my god.
They had to put,
girls
like-
didn't have a lock.
So you came home last
Yes.
night, and that sounds like a good thing.
But now you gotta do this. I'd rather sleep with the bugs.
Poor Miss J.
You could have made a friend.
Poor Miss J. Young teacher trying to deal with.
Well,
That's
they can't find hotels since there's 70,000 people there.
Right.
And
You guys probably would have been better off driving home last night
Sleep in the bus.
and coming back and going back in the morning.
I would have slept in the bus gladly.
Okay, example 3. Write a polynomial function of minimum degree in standard form with real coefficients whose zeros include x equals 1, x equals 1 plus 2i, and x equals 1 minus I.
And,
Oh, and? What do you mean and?
well, there's more, isn't there?
There's more?
Let's wait.
Because the 1 plus 2i.
2i minus I.
Don't
There's
try and trick me.
5.
Okay,
5.
we need our conjugates, yes?
Yeah.
X equals 1. Do we worry about a conjugate there? No, because it's not a complex zero. It's not imaginary. So that one's just good. What do you know about 1 plus 2i?
There's another one.
That's another
It's
one.
hidden.
X minus 2i.
Wait,
J.
something x minus 1 minus 2i.
Okay, so my 0 is going to be 1 minus 2i.
Yep.
And what do you know about 1 minus I?
1 plus.
We're going to have the 0 of 1 plus I.
Oh wait, I don't think it did.
Now, as you go and write these out, put conjugates next to each other. Do not put them in this order or you will regret it. Because not as much will cancel out. You want to multiply conjugates. I cannot stress that enough.
Wait,
And as I said, I already told you guys, I ran out of room on my notes doing this, so beware. Okay,
I'm writing my
x equals 1. What do we know about x equals 1?
X plus minus 1.
X minus 1. Okay, 1 plus 2i. What do I know about 1 plus 2i?
X minus 1 minus 2i.
Okay, so I'm going to write it to begin with as x minus parentheses 1 plus 2i. However, if you want to jump, what did Stetson just say? X minus 1 minus 2i is what that will become, yes? I am perfectly fine with going straight there. Now, I just wrote the factor for 1 plus 2i. Your smart move would be to do 1 minus 2i. So x minus the parenthesis, 1 minus 2i. Because it's x minus that whole 1 minus 2i, which is going to become what?
Plus.
X minus 1 plus 2i. If you are skipping that first step and just doing the second step, that's fine, as long as you know what you're doing. Now, 1 minus I is a factor. X minus the quantity, 1 minus I, which becomes x minus 1 plus I. And
X minus 1.
x minus the quantity, 1 plus I, which is x minus 1 minus I. Okay. I cannot stress the importance of being smart about the order you multiply these in. That x minus 1 is just going to hang. I'm not going to mess with it yet. Okay? Because I don't have anything to multiply it with. Because I want to do my conjugates. Because if you multiply your conjugates, the i's are all going to cancel out right away. If you don't multiply conjugates, you're going to have more terms to work with and just more mess. Okay? So, carrying down x minus 1. Right, small, right? I'm going to have 9 terms and then 9 more terms. So, x times everything in its other parentheses. So, x squared minus x plus 2ix. Negative 1 times everything in the next parenthesis. Minus x plus 1 minus 2i. Minus 2i times everything in the next parenthesis. Minus 2ix plus 2i minus 4i squared. There's 179. You can come back and do the other side of 9 later if you want, or we can do it now. So I'm going with this x here times everything in the next parenthesis. X squared minus 1x minus ix. Middle negative 1, I'm going to distribute it. Minus 1x plus 1 plus 1i. And I'm going to distribute the I. Plus ix minus 1i minus I squared. Okay. This x minus 1 hanging out front is still hanging out front. These 9 terms should simplify into 3 terms. Okay? What do you see happening? 2ix minus 2ix is gone. Minus 2i plus 2i is gone. And minus 4i squared will be plus 4. Okay, clean that parenthesis up. X squared minus x is going to be minus 2x plus 1 plus 4 plus 5. Okay, clean up your next parenthesis. I know I should have some canceling again. Minus ix plus ix plus I minus I, and minus I squared will be plus 1. So I have x squared minus 2x plus 2. Okay, all your eyes should be gone at this point. Folks, if you hit this point, all of your eyes aren't gone, stop and backtrack now.
That'd be terrible.
Okay.
I think I just give up.
But the point is, don't go forward, right? Don't go forward, it's a waste of time. Back up and try and figure out what went astray. Now, we have 3 things to multiply, yes? Pick 2 and go with it. Personally, I was going to do the 2 trinomials and save x minus 1 for the last. But you don't have to go that route. Okay, so x minus 1 I carried down. Okay, I'm going to distribute x squared to the other parenthesis. X to the 4th minus 2x cubed plus 2x squared. I'm going to distribute minus 2x. Minus 2x cubed plus 4x squared minus 4x. I'm going to distribute 5. 5x squared minus 10x plus 10. X minus 1 carries down 1 final time. And I'm cleaning up. X to the 4th carries down. Negative 2x cubed and negative 2x cubed. It's negative 4x cubed. 2x squared, 4x squared, and 5x squared is 11x squared. Minus 4x and minus 10x is minus 14x plus 10. And one last distribute. Now this is the easy distribute because x times everything just increases powers, minus 1 just changes sign. So, x to the fifth minus 4x to the fourth plus 11x to the third minus 14x squared plus 10x. Distributing by minus 1. Minus x to the fourth plus 4x cubed minus 11x squared plus 14x minus 10. Well, I know it begins with x to the fifth. Minus 4 minus 1x to the fourth, so minus 5x to the fourth. 11x cubed and 4x cubed is 15x cubed. Minus 14x squared minus 11x squared. Is that all I have? Minus 25x squared. 10x and 14x is 24x minus 10.
Nice.
Did I make any mistakes?
No, that's right.
I hope not.
Man, I really
Okay. If you want to start working on homework, you have some of these you can start working on today while they're fresh in your head. We will look at examples 4 and 5 on Monday.
I'll be back.
Okay.
I'm gonna go tell Mr. Buffkin
Sounds like a plan.
I have a quiz.